This is a quiz, testing my knowledge of the BaggingRegressor in Sklearn, a powerful machine learning library. I'll be focusing on its hyperparameters, the settings that control how the model works. This is the core question. I will evaluate several statements about BaggingRegressor and its settings. I'll determine which ones correctly describe how it behaves. I need to determine if increasing the number of estimators, estimators in BaggingRegressor improves the model's accuracy. I also need to check if this comes at the cost of increased computing time. More estimators usually lead to better accuracy, but they can make the model slower. Here, I need to consider the bootstrap parameter. Setting it to false means I will use pasting, a method similar to bagging but without replacement. I'll check if this statement is accurate. Bagging uses random sampling with replacement, while pasting uses random sampling without replacement. This statement claims that max_samples controls the number of features used. I need to check if this is correct. I should remember that max_samples actually controls the number of data points, rows, not features, columns. This statement says that BaggingRegressor helps prevent overfitting. I will determine if the method of creating an ensemble of various estimators prevents overfitting by averaging the predictions and reducing the variance. Overfitting happens when a model performs well on training data but poorly on new data. This instruction tells me that I might need to select more than one statement as being correct. I must carefully consider each option. This quiz tests your knowledge of the BaggingRegressor model in Sklearn. We'll explore its key parameters and how they affect model performance. Get ready to put your machine learning skills to the test. This question asks you to identify correct statements about BaggingRegressor and its settings, hyperparameters. We need to carefully assess each statement using our understanding of bagging. I'll explain this. Increasing NESTIMATORS, the number of base estimators, generally leads to a more accurate model because you're averaging the predictions of many models. However, more models mean more calculations, resulting in longer processing times. It's a trade-off between accuracy and speed. Let's talk about BOOTSTRAP. Setting it to FALSE means we're using pasting, which is a sampling method that doesn't allow replacement. Unlike bagging, where samples are drawn with replacement, each data point is used only once in each subset. I want to clarify this common misconception. MAXSAMPLES actually controls the number of asterisk data points sampled, not the number of features. The number of features is controlled by MAXFEATURES. It's an easy mistake to make. This statement highlights the core benefit of bagging. By combining multiple models built on slightly different subsets of the data, BaggingRegressor reduces the impact of individual model errors. This helps prevent overfitting, which occurs when a model performs well on the training data but poorly on new, unseen data. Think of it as a safety net. These are the options for your quiz. You need to choose the statements that correctly describe how BaggingRegressor works and its hyperparameters behave. I'm going to explain the important hyperparameters of BaggingRegressor, a machine learning model that uses a technique called bagging to improve prediction accuracy. We'll explore how these settings affect the model's behavior and performance. It's like having a team of expert advisors, each providing their opinion, and the final decision is a well-informed average. This question tests your knowledge of BaggingRegressor and its settings. You need to identify which statements accurately describe how it works. Let's analyze each statement carefully, considering how each hyperparameter interacts with the model's construction and performance. Think of it as a multiple-choice quiz on BaggingRegressor's inner workings. Increasing the number of estimators, N_estimators, means I'm adding more models to the ensemble. More models generally improve accuracy because I get a better overall average prediction. However, the more models I use, the longer the model takes to train and run because I'm doing more computations. It's like having more advisors. The advice is better, but it takes longer to get it. BaggingRegressor uses bootstrapping by default, which means it samples data with replacement. Setting Bootstrap to false changes this to pasting, where sampling happens without replacement. Each data point is used only once in each subset of the data. This is a subtle, yet important, difference that can impact how each submodel is trained. This statement is false. Max_samples controls the number of data rows, samples, not the number of features, columns, used to train each individual model. It's like deciding how many patients' data are used, not how many test results are considered from each patient. The parameter to control feature selection is _features_. This is true, because BaggingRegressor uses different subsets of the data to create multiple individual models. It gets a more robust prediction by averaging the results. This reduces overfitting by not relying too heavily on any one piece of training data. The core idea of BaggingRegressor is to create an ensemble, meaning a group, of models. Each of these models is trained on slightly different subsets of the original data. This way, the final prediction is an average of the predictions from each individual model, and this average tends to be more accurate and robust than any one individual model's prediction. By averaging multiple models, BaggingRegressor tends to reduce overfitting. Overfitting happens when a model performs well on training data but poorly on new data. Bagging helps to mitigate this by reducing the variance of individual model predictions. This quiz tests your understanding of BaggingRegressor, a powerful tool from the Sklearn library used for building regression models. We'll explore its key hyperparameters and how they affect model performance. Get ready to test your knowledge. This question presents several statements about the hyperparameters of BaggingRegressor. You need to identify the true ones based on your understanding of this algorithm. I'm asking, does increasing the number of base estimators in BaggingRegressor generally lead to better results? Increasing the number of estimators typically improves accuracy, but remember it does add more computational cost. Think about the averaging effect. I'm asking, what happens when I use in BaggingRegressor? Setting switches the algorithm from bagging, sampling with replacement, to pasting, sampling without replacement. I'm asking, how does BaggingRegressor help prevent overfitting? BaggingRegressor creates multiple models from different subsets of the training data. By averaging their predictions, it reduces the impact of outliers and decreases the model's sensitivity to noise in the training data, leading to better generalization and reduced overfitting. I'm asking, does the maxsamples parameter in BaggingRegressor control the number of features? Nope. The maxsamples parameter controls the number of data points sampled for each base estimator. The number of features is controlled by maxfeatures. I'm focusing on the key settings that control how BaggingRegressor works. These settings let you tweak the model to get the best results. Think of them as the knobs and dials on a sophisticated machine. This is simply the number of individual models, called base estimators, that BaggingRegressor creates and combines. More is usually better, but it slows things down. Think of it like having more votes in an election, more opinions to average. This setting decides how BaggingRegressor gets its training data for each individual model. If it's true, the default, it uses bootstrapping, sampling with replacement. That means it can pick the same data point multiple times. If it's false, it uses pasting, sampling without replacement. Each data point is used only once in each individual model's dataset. I'm using this to control how many data points each base estimator trains on. It's a percentage or integer value, not a count of features. Let's say I have 1,000 data points. If maxsamples is 50%, each model will train on roughly 500 randomly sampled data points. This isn't directly mentioned in the lines you asked about, but it's important to contrast with maxsamples. Maxfeatures controls the number of asterisk features each model uses, not the number of data points, samples. It's an often confused setting. These are the individual models that BaggingRegressor combines to make a more powerful and robust prediction. It could be decision trees or something else. BaggingRegressor averages their predictions. I'm talking about the settings you can tweak in the BaggingRegressor model, like the number of trees you use or whether you sample data with or without replacement. These settings directly impact how the model performs. This is a multiple-choice quiz, testing your understanding of the BaggingRegressor model and its parameters. We'll go through each option. This controls the number of trees in the BaggingRegressor's random forest. More trees generally mean a more accurate model, but it also takes longer to train. This setting determines how many data points I randomly select to train each individual tree in the forest. It does not control the number of features. This is a Boolean value, either true or false. When true, I sample with replacement, bagging. When false, I sample without replacement, pasting. This parameter, not mentioned in the original questions, controls the number of features randomly sampled for each base estimator. I'll explain the hyperparameters of the Sklearn BaggingRegressor. Bagging, or bootstrap aggregating, is a powerful ensemble method that combines multiple models to improve prediction accuracy and reduce overfitting. Understanding its hyperparameters, n_estimators, bootstrap, and max_samples, is key to using it effectively. This question tests your understanding of BaggingRegressor's behavior and how its hyperparameters affect model performance. We'll examine each statement carefully, using my knowledge of BaggingRegressor and the principles of ensemble learning to determine their validity. Get ready for a deep dive into machine learning concepts. This hyperparameter determines the number of base estimators, individual models, in BaggingRegressor's ensemble. Increasing this number generally leads to better model performance, as it leverages the wisdom of the crowd effect. However, more estimators mean longer training times and greater computational cost. It's a trade-off between accuracy and efficiency. This Boolean hyperparameter controls sampling with or without replacement. Setting bootstrap equals true implements bagging, where the base estimators are trained on random subsets of the training data with replacement. If it's false, we use pasting, sampling without replacement. Each data point is used only once per subset of the data for each model. This parameter specifies the number of samples, data points, to randomly select for each base estimator. It's crucial for controlling the diversity of the models in the ensemble. Note that it doesn't affect feature selection. That's controlled by the _max_features parameter.